Now let's look at a very typical problem in 1D motion. Given the velocity function vt, and we need to find the displacement and distance from time dt, t sub 0 to t. So that means for one time interval. So very, very typical problem. Okay, so how do we work on the first question here? Find the displacement. Okay, so we start from here. We all know that v is the derivative of position versus time. So v equals, so of course, x is also a function of time t. So v equals dx over dt. Now we can multiply dt on both sides. We got x equals v times dt. And then integrate on both sides here. From what? From t sub 0 to t. We got dx integral from t sub 0 to t equals t sub 0 to t v dt. And again, here we know v is a function of t. So I don't write the parenthesis t right here, but we keep this in our mind. The left side, what does this equal to? So when x equals t, that's the final position. When x equals t sub 0, that is initial position. So therefore, the left side is actually equal to, we can write this, it is called displacement equals the integral of v dt, and then we take the two limits from t sub 0 to t. We got the displacement formula. Okay, so that will be the answer for question 1. So find the displacement. We simply do the integral for the v function from initial moment to final moment. So there are two things I want to remind you. I put start here. First, t sub 0 does not need to be 0 all the time. So t sub 0 can be any initial moment, or can be any moment. We call it initial moment. It can be t equals 2 seconds, 3 seconds, 10 seconds, does not matter. So try to change your mindset here. T sub 0 does not mean t equals 0. The second one I want to remind you, when we get the integral, delta x, the displacement, can be positive, can be negative as well. So whatever this integral gives us, delta x equal that value. Okay, so now let's move on to the distance. So what's the difference between the distance and displacement? Let's look at this. Okay, so I have one object is moving along the straight line here at initial moment. So then t equals 0, t equals t sub 0. So during one time interval, this is my initial moment, t equals t sub 0. And what I know, let's suppose this object has a positive velocity. So that means it is pointing to the right if this is x positive direction. And then we want to know when it gets to t equals t, the last moment, the final moment, what the distance is. So let's see if this object during this time interval, so time goes on here. If v, we know v is changing. If v is always positive, so it moves to the right here, and then suppose this time t is still positive, then we get that this will be the displacement. And this displacement will be identical to the distance that it moved. But there is one special case. Let's see. This object is moving to the right with one initial velocity v sub 0, but it slows down. It has some acceleration. So it slows down, and then at some moment, not to final moment yet, at some intermediate moment, the velocity here, v turns into 0. And then what happened next? So it will move to the right, and then after it hits this moment, it turns to go back, turn to the left, because time still goes on. It hasn't reached my final moment yet, because the velocity is changing. Now the velocity turns into a negative value. So now it moves to the left. So suppose, okay, so that will be the last moment, t equals t. Okay, so my last moment right here, final moment here, and this is where the object is. This is its final position. So it's initial position here, this final position, this x sub 0, and this is x. Now let's look at what is the displacement. So the displacement delta x always equals x minus x sub 0. It really does not matter. So this object moves to here and then turns over. I don't mind. I just look at initial position minus initial position. So this will be my answer for the displacement. But when I look at the distance, let me call it d. Okay, so that's, we can choose any symbol. What d equal to? So d equals the total length that the object has moved. We know that initially it moves from here to here. So I call this d1. And then when it turns back, it moves another distance. That is d2. So d total distance equals d1 plus d2. What is d1? d1 is the distance. It moved from when velocity is v sub 0 to what? To v equals 0. So this will be a moment. So I don't know. We have to figure out what this moment is. We might call it t1. So at t1, v equals 0. And then we can figure out how much it moved. What the distance? So the distance and displacement from here to here will be identical. So d1 that's equals delta x1. And when it turns back, it moves from what? From v equals 0 till this last moment. So this last moment v here. So from this moment t1 to t, the object is moving along the negative x direction. So let's see, from here to here, the displacement is delta x2. So we know that from here to here, the displacement should be a negative number. So delta x2 is less than 0. So the distance always equals the absolute value of the displacement for one time interval if it moves along the same direction. Okay, so then what is d2? d2 equals delta x2, the absolute value. So to answer the question, what is the total distance? We have to pay attention to, does the object change the direction or not? If there is one moment during this interval, the velocity is 0, it means it will make a turn. So the displacement will get smaller, but the distance will keep increasing because distance always equal to the absolute value of the displacement if it moves along the same direction. So from here to here, same direction. From here to here, same direction. But for the entire time interval, the velocity does not have the same sign. The direction of the motion has changed. So that will be the key point. So for one of our problem in the homework, so I want you to pay attention to what, figure out the moment. So find the moment t, we call it t1. Okay, so find the moment t1 when v turns to 0. So that will be a very key value. Then you figure out the displacement from t sub 0 to t1, and then from t1 to our final moment 2. So break the entire motion into the 2 segments, t sub 0 to t1, t1 to t. You can find out total distance.